whatever the operation that you are trying to perform on a particular circuit, you are going to give certain inputs, it is going to produce certain output, right? If this output is going to generate only single operation term, I can call it as degenerative function. I can call it as degenerative function, meaning that whatever the output that circuit is going to produce, if it is going to produce single operation term, I can call it as degenerative function. So what is the meaning of this one? Meaning that whatever the term that I am going to get as output, that term I can able to simply implement with help of only one gate. For example, assume that my output is ABCD. Can I able to implement with help of four input AND gate? Yes or no? So simply I can take 4 inputs A, B, C, D, that I can call it as degenerative function. On the other hand, another kind of function is there, non-degenerative function. What is the meaning of this one? It is going to produce, meaning that this circuit is going to produce output in the form of sum of the products or in the form of product of the sums. If I am saying that it is in sum of the products or in the product of sums, what is the meaning of this one? It contains more than one term, right? If I am trying to say that A plus B into B plus C, this is my result will get. This is what product of the sums. Or AB plus CD. This is the example for some of the products. Right? So this expression I can call it as non-degenerative function, where if it is going to produce only single operation, I can call it as degenerative function, right? At what situations you may get degenerative functions? At what situations you may get degenerative functions? Can you able to tell? What are the chances to get some of the products or product of the sums expressions? Can you give some examples? Like for example, try to take AND/OR circuit. AND/OR circuit, is it going to produce some of the products? Yes. So the output which is generated by AND/OR combination is always going to be a non-degenerative function. Similarly, OR AND is again it is going to produce product of the sums. I can call it as non-degenerative function, right? Is there any combination where it is going to produce only single operation? No. Right? For example, try to take a simple example. I am trying to take AB and CD is on 2 inputs, and I am trying to produce an output with AND gate again. What is the output you are going to get? ABCD, right? Again, this is a kind of a term which is having a single operation, meaning that completely AND operation, right? Then I can call it as a degenerative function. Right? What is the combination for to get degenerative functions? AND. So AND is one possibility, is one of the possibility to get degenerative function. Similarly, there are certain other possibilities are there that I am going to write. AND NAND gate functionality. AND NAND gate combination also is going to produce degenerative function number. RR, similarly, RR is going to produce single operation or not? For example, try to take or finally again it is going to produce an OR operation, right? A, B, C, D as input, A plus B plus C plus D, right? Meaning that A plus B plus C plus D, again they are going to implement with help of only single operation, single 4 input OR gate I can able to do. So that is what I can call it as degenerative function. So RR is also one possibility. Similarly, OR NOR. See, if we are going to have main gates and OR NAND NOR, how many combinations are you going to get? 2 power 4 combinations you are going to get, right? 2 power 4 combinations means total 16 combinations you are going to get. Out of the 16 combinations, 8 combinations are meant for degenerative functions and 8 combinations are meant for non-degenerative functions. Non-degenerative, right? What are these 8 combinations means? I am trying to write here. Another one is NAND or NAND NOR, NOR and NOR and NAND. These are the 8 combinations that if you are going to use in our circuit, it is going to produce a degenerative function. Right? If you are going to take all the remaining combinations, they are going to produce non-degenerative functions. Right? So I am going to write. So one is AND OR, another one is OR AND, another one is AND NOR combination, or NAND combination is possibility is there. NAND NAND combination, NAND and combination, NOR NOR combination, NOR OR combination. Okay, so these are the other 8 combinations which are meant for to define non-degenerative function. Sir, do we remember do we need to remember all this means? No. Just when they are going to ask you, try to implement some simple circuit. If that simple circuit is going to produce degenerative or generative, based on that you can tell the answer. That's it. No need to by heart anything, right? Okay, fine. So try, for example, I am trying to take simple thing. For example, AB as input for OR gate. What is the output you are going to get? A plus B. A plus B. And I am going to take one more combination, which is, what is this one? NOR. NOR, right? So what is the expression you are going to get? A plus B plus C whole bar. A plus B plus C whole bar. What is the output you are going to get? A plus B bar dot C bar. Finally, we are going to do A bar dot B bar dot C bar, right? So meaning that it is going to result into one single operation or not, right? Then I can call this terminology also OR and NOR is also comes under degenerative function.